Alright, old gatekeeper here. Here with Mr. Kevin's third amplifier. We have a Sweet 16 DX 1600X straight 8 pill, A, B, and C switchable. Pretty much says amps burning up input or combiners. I can see why already. Upgrade ferrite. It's a blank canvas. Oh goodness. Can we add 2 additional transistors to make it a 2x8? We already talked about that over the phone or over the email. To basically convert this over to a what's that model number, to a 1600V, it'd be a good bit of work, man. It'd be a good bit of work. That 1600V is the most sophisticated amplifier Texas Star has made to date. It's a very neat setup. It's staged. You can turn the 2 transistor section on and off independently, 8 transistor section on and off independently, or run them both together. It definitely can be done. There's definitely nobody or done any favors that I've seen and wrote up an actual, step 1, step 2 on doing that conversion. So if somebody ever really did want to do that, I would have to sit down and write that up, compare this version with that version. There is quite a bit of rewiring that you would have to do, and they even got different switches on the front, for that. It says driver and final and all that good stuff. But you basically said, don't worry about it. We'll just keep it as it is, which I would say is a pretty wise decision. That would be a little bit of labor. Anyway, just looking around here, man. I noticed 2 things that were kind of odd to me at first. One was, it appears that somebody has changed the biasing resistors right here. I don't know why they done that, but I wouldn't think this would be done by factory. I've never seen Texas Star have 2 different. I mean, they're all 25 ohm 5-watt resistors, but I don't know, maybe it's a possibility they were out of these and used them. But the main thing I see that's wrong with this is there's 2 HGs over here, and the rest are DEIs. You can't do that. I know a lot of people will swear up and down that HGs and DEIs are the same exact transistor. They are not. They are not. They're 2 total different transistors. So either this section right here is going to make these other sections work harder, or these sections are going to make this right here work harder. Whichever I can pretty much see by looking, we have a blown transistor somewhere. But so we're probably going to have to get these HGs took out, and I might have to go. I got a bag of like 100, 200 DEIs. I'll figure out something, get a big match set, and in the future, if you can ever afford to, I would replace these with Toshibas if you can afford to. And secondhand, is replace them with HGs. And I would give you a ring about that, but I do not have any HGs right now that I can use on this. I'm waiting on my next stock right now, and it'll be here in 2 or 3 days. By that time, I'll be done with this. But alright, man, I'm gonna go ahead and dig in here and see what's going on. Maybe this one will be a little quicker repair than the others. And as I talked to you about the power wire upgrade, this is the toughest amp to do a power wire upgrade with, because I really wish they would have made this amp longer. I wish they would have made this amp longer and a little wider. Well, I understand what they were trying to do with this, but now you only have 1 fan instead of 2, but you got a lot of extra protection circuitry. But the reason I'm saying it was so hard to do a power wire upgrade is because, or the way that I like to do it all the way to the back of the transformer. If you look right here at these two transformers, you can't get to the back of them, man. I mean, it would be one very tricky chore to get chokes and all soldered. I mean, it's just too crowded right here. These would be no problem. These would be crowded. Now, if someone's ever done a power wire upgrade to one of these, I would like to see pictures of it. I'm not saying I couldn't do it, but it would be a chore. I would probably have to remove a lot of wires to get to the section. But I am going to do a few. Alright, big brother, we got all the transistors removed. The beautiful thing about Texas stars, tough to test them in circuit, get all the solder away from the tabs, but you're going to have to remove all these anyway. Alright, what we're looking at here, I can tell that you didn't run this much, or if all, after you, excuse me, there I go being about you, or after you or whoever put these HG08s in here, because these bad boys are brand new. The HFE on them's like they haven't even been used hardly at all, if any. So for the rest of the transistors, you pretty much have 3 with no gain at all. They're not even picking up any HFE at all. They're not even being ran as a transistor. That's these 3. And these have HFE of 3. See if I can zoom in for you. Have HFE of 3, 2, and 2. So I mean, it wasn't going to be much longer, and these are going to be reading as no transistors either. So don't get me wrong, these transistors could probably still work, but it won't be long, man. These are going to go out on you. I mean, they're I don't know, maybe you were having the problems and getting the imbalance from having these in here, because these right here are pretty much brand new. They're brand new, they appear. So it's probably putting a lot of strain, or these were attempting to pull them down. But I'm working on a solution for you, man. I got bags of DEIs I pulled from. I still got about 3 or 4 times more than that. I'm gonna see if I can't find a good matching set of DEIs for you to put back in here that have some gain. Or I may even see if I can scrounge up some HGs for you. I don't have any new HGs right now that I can use for this. My stock's supposed to be here tomorrow or the next day, and they're probably all accounted for, man. These things are going out so quick. I basically have to get customers to purchase any transistors that I'm going to be using for a repair. That's just how quick they're going out. But we'll figure it out. Get it all straightened out for you. One thing I did go ahead and do, man, because this is the joys of being able to work on all kinds of different amplifiers out there. I'd always been curious how they were switching back and forth from A, B to C in this amplifier and the 800V, I believe it is, which you don't see much of. It's the 4-pill that's got A-B switchable as well. And I will admit, I was kind of let down. I was hoping for something a little bit more sophisticated than this, but hey, it works. I just was thinking it was going to be something a little more sophisticated. But I will tell you one thing that was pretty unique that I discovered. And at first I couldn't figure out what in the world this capacitor right here was for. This is a 68 picofarad capacitor, or puff as some say. I couldn't understand why was this intertwining with a Class C. This is basically a Class C relay. This is the AV relay. That's pretty much what's going on in a sense. But really, this relay has really nothing to do with the Class C other than what's going on here is this. If you take a look at a Texas Star biasing circuit. It is absolutely the most simple voltage biasing circuit that can be done. It's a simple voltage divider circuit, straight to the point. It's a 25 ohm resistor, sandbar resistor, 5 watt, and a 1.8 or a 1.6, or sometimes you'll see a 1.5 in the old school ones, small quarter watt resistor, but it's a voltage dividing circuit like this. Okay, so you'll see that this, in a sense it's showing this, or unless it's clear, for example, would be the 1.8 ohm, and this would be the 25 ohm. The voltage comes in this direction, okay? And as you see, this right here will carry on to the chokes. I don't know all my symbols, you know, I'm not perfect with this. I can't remember a symbol for a choke, but this basically will carry on to the transistors. To the base of the transistors. I'm drawing looking through my phone. Like that. And basically all this choke right here is for is to allow DC to flow through while blocking any AC remnants. If there's any sort of AC signal at all present on this side of the choke, it's going to make sure that no AC remnants of AC at all can go through this choke this direction or this direction. If you got any sort of dirty AC or something around this direction, this choke right here is going to allow the AC to not flow through it and only let the DC flow through it. Okay, for example, if you change this choke right here with a capacitor, you know, it wouldn't work because DC cannot flow through a capacitor in series. Pulsating DC can, but we won't get into all that. But DC by itself could not flow, so we use these DC, we use these capacitors to actually block the DC. And you'll see that's used in the Texas Star circuit with this circuit, which is in a different portion of the circuit to block any DC from getting in to the circuit. So it's basically going to be, I look at it like someone standing in the middle of the road saying, DC, you flow this direction, and AC, you flow this direction. So anyway, that's the most simplest circuit you can have, man. And it's straight to the point. It works good for what Texas Star needs it to work for. And there's definitely a lot more advanced circuitry that you can use in biasing, which I have been studying for the last couple of years. But for what this is, for what this amplifier is made for, it's straight to the point. Alright. Now, this is why I drew this. I know this thing, it's just a little education lesson. Something told me just to share it. Anyway, some of y'all may be interested. If not, you can fast forward through all this. So, if I remove this voltage from the whole matter, if you notice, the bases of these two chokes, the bases of these two transistors, excuse me, if this was a regular Class C amplifier, we would have a choke connected to these two bases of these transistors going to ground. Okay? Well, if you take a look at this, here's a choke, right? If you follow this, and by the way, I have tested the type of ferrite that Texas Star uses. It's actually pretty remarkable the amount of inductance that it is just with one turn. This is considered one turn. Taking a wire and going straight through a ferrite bead. That's considered one turn in the RF world. Same if we took it and sent it through the transformer and back out once without actually wrapping it through. That's one turn. Alright. Here's a choke, right? Well, if you look at this resistor, it's taking this resistor. You don't even have to worry about what's going on over here. I'm saying if there's no voltage applied to this 25 ohm resistor, the base of these two transistors is grounded through this resistor. I keep saying the wrong thing. I'm sorry, y'all. The bases of these two transistors, which I think I did say that, but is already grounded through this choke down this resistor to ground. This is ground reference down here. So if you took a voltage away, it's Class C. You have a little bit of resistance right here, but it's Class C. DC can flow through this choke. That's what it's made for, to block any AC. Okay? And it's grounded. So that's what Texas Star is doing. They took advantage of how their circuit was already set up, so they didn't have to add any more sophistication to it. So, as you see, this right here is the positive point of the relay, right? So this relay is only going to be getting voltage when you got the on button on. So saying that, once you turn the on button on, the relay right here's got voltage. Okay? That'd be a little different than some of the other Sweet 16s, but just follow me right here for this particular one right here. The other Sweet 16s would be a little different. This wouldn't have voltage until it's keyed. And I don't believe this one could be set up like that too. I didn't look further on down the circuit. But whether or, it don't really matter when it's keyed or not keyed. As soon as this relay gets the voltage, okay, you have voltage present going down this wire right here at the switch. All right, when this switch is flipped over to AB, I always remember with most switches, when you flip it over, the leads are connecting to the opposite direction. So yellow is connected to blue. So voltage flows this way through blue to the part of this coil of this relay. Okay, this right here is connected to the hot bus of the front left board. So then DC voltage flows this way through the relay to this lead. These are just simple SPST relays to this lead on the all four boards, sandbars. So basically I can actually go ahead and draw it like this. Booyah. I didn't even think about that. So the voltage flows through like this to all sandbars. Okay. Alright, when you flip the switch this way, the way it's set right now, voltage comes through this way from the main relay when it's keyed, or when this relay has voltage. Okay. And instead of voltage going through the blue, now it's going through the brown line here. Then this relay is actuated. Now this relay is not actuated. Okay, so without this relay being actuated, there's no voltage going through here. So now base of these two transistors, they're grounded through this 1.8 ohm resistor. So they're in Class C. They're grounded. So this relay has nothing to do with the voltage point. What's happening here, which is pretty unique, is this is just adding a 68 picofarad capacitor to the input tune. So that's pretty unique. Myself, I never thought there was a reason to change tunes with bias, but for some reason Texas Star believes that for some reason they needed to, and they did. So that's what they done here. When you're in AB bias mode, there's a 120 picofarad capacitor for your input load, your input tune. When you're in Class C mode, this relay actuates when you key. Okay, I'm sure that relay doesn't get the voltage to your key just like the old ones. when this relay right here keys, it's probably sending the voltage to the main relay. But anyway, I just didn't draw that into the schematic. So when you key, this relay actuates and adds a 68 picofarad capacitor to the 120. And that becomes your input tune for Class C. So that's the first time I've seen that happen. I've thought about it just in theory, but they're actually changing the tune, the input tune, upon transmit of each version. So I thought that was pretty neat. Sorry, didn't mean to take up all that time. Now let me get my butt back to work. We'll see you. No gatekeeper here. Oh. Out here around northeast end of Georgia, I'm working as hard as my physical body will allow me to. Trying to get y'all's repairs done, your builds done. On the most part, everybody's been very good and very patient, you know, and I'm highly appreciating that. Big time. That's what makes my end so much less stressful. But basically, I usually go on vacation one time a year with the kids. You know, I got 2 young kids, as everybody knows, or most people knows. They're 8 and 10 years old right now. And anyway, this year I honestly may not be able to go, but it all depends on how much work I really get done this week. But yeah, I don't know. It'd probably break the old kid's heart. My brother, old Dan the man, the CB counselor. Some of y'all have already heard old Dan the man out there before. He's a comedian, I meant to say. He's a funny fella. He also teaches people how to rap for a living and actually makes a living doing it. How wild is that? Could you imagine somebody could actually teach people how to rap? Like, gatekeeper making amps, dropping malls on these cotton picker slant, or something like that, rapping. He's a good guy, man. My brother's a blessing. But anyway, he and his wife's going to be going, so if I couldn't go, they could at least watch after the kids for me. But anyway, I'm basically just making this video real quick, just to let everybody know I'm going to be selling a few things this week. So be watching that on my YouTube account. Just to raise a little bit extra cash, just in case I can go on vacation. Because had a little issue getting that preamp released. Had some twerks I had to get worked out of it, and it took me a couple of weeks to do that, which means I wasn't doing anything else, so it kind of hurt me a little financially. Hey, we all human beings, and we all struggle financially sometimes, unless you're a rich cotton picker. But I'm no rich cotton picker, I promise you that. But, so anyway, and I just put 4 GK pre's for, I think, $20 off on eBay. So anybody that's been wanting some of the GK pre's, you better hurry up and go to eBay and grab you one or grab you 4. And just want to let everybody know that I'm going to be putting a couple of things on eBay throughout the week too, and hope to raise a little bit of cash so I can go on vacation and hopefully just take a week off from work. But knowing me, I'll probably bring some things with me to do some work while I'm there. And I got to... Alrighty, Mr. Gatekeeper here. If you see any smoke, I am doing a little celebration sig here. This is Mr. Kevin's 3rd amplifier he sent to me. And basically, bud, I just made the best decision I could for you. And what we went ahead did is basically put you in a set of 8 matching HGs. Okay, they are used HGs. Let's see here, bud. These 2 right here, wherever they are, the 2 that you had in there, I know now why they're new. And I could tell that none of the HFE had been brought down with them, was because this fuse was right here was blown, which it's very hot out here in Georgia, and I may have to set up another fan blowing on my phone just so it'll quit overheating. But I see this happen a lot with this model amp right here. They got a fuse in line with the RF that comes in the amp, flows through that fuse before it even gets to the relay. Okay. Now, I didn't have any 1 amp fuses laying around. I've been meaning to order some. What comes in is a 1 amp 250 volt fuse, and these aren't your normal bus fuses. These are, I believe they're 1/8. I'll let you know. I had to put, I think, like a 5 amp in there, so it's up to you. But if you want to, you can order a 1 amp and put it in there, and basically that's just, you know, if you drive a little bit over 100 watts plus into it, it's going to blow this fuse. And it happens so much. I see it happen all the time. All the time. And that's just one of Texas Star safety features. Basically what they did is took half the heat sink away, made it smaller, but added a heck of a lot of protection to it. And I wish it was still, you know, twice the amount of heat sink, and it'd be nice if it still had this twice the amount of heat sink and still had all the protection they got in this now. That would be neat. You know, it just makes it a lot more safer. Anyway, we're going to have to do this a little bit different, okay? Like I said, I don't have a big regulated supply right now. Back when I get back from vacation, I'm going to either go ahead and get one built, or if I can make myself have time, build one myself. So I'm gonna be going on vacation here in about 3 weeks or so. That's what I got planned. Alright. I would have hit you up and asked you about putting a brand new set of 8 in here, but I'm in between. These HGs are selling so quick. I'm in between shipments, and not too long ago I had one that was held up by in the beautiful land of postal air. But luckily these were a set that came out of a brand new build that a guy did, and he said he didn't even run it. He ran it for about basically just testing it, and he's like, you know what, I want to build a 32. So I worked out a deal with him. He sent me the 16 back, and worked out a little deal and sent him 32 matching ones. So these right here were pretty good. I'd say they were about maybe a little bit more, 75% of the HFE value they were when they're brand new. So you should be good to go with these bad boys. You'll see that just you don't go by the numbers that's written on top of them. You'll see 62 on all of them. These back here has 60. They're all the exact same HFE right now. I believe they're sitting at 32, I believe 32 or 34. Every single one of them, so they're all matching. All right, but basically what I said, we're going to do this a little bit different because my bench radio is not pulling this supply down to a safe operating voltage. And this amplifier is a little different than some of the other Texas Stars. The resistors that's on these LEDs are like 680 ohms, I believe. And there's a few other things too. I'm just going to kind of do some quick burps, and we're just going to go ahead and hit it with the hot radio starting off. Since we do have a Class C switchable, Class C AV switchable, I'm going to, just for the fun of it, hook up the old 2-pill and hit it on the Class C one time in the end. And after all that, I'm going to unhook everything and hook this up to this regulated supply just with the radio to show you the input reflect. It's great. Hardly no reflect at all. And just point out the neat little situation they got going on here, how they got different input tune on A, B, or C, whichever one. It adds this 68 picofarad capacitor in with it. Alrighty. Alright, so right now we got the hot radio hooked up, which is going into the 1 transistor amp, the old epoxy 1-pill. And after all this too, man, my mic went out on me. Just all this stretching in and out, in and out. I think it needs to be rewired. What you think? So I had to find me another mic and hook it up. So I don't know how well this mic works with everything, but it seems like it's doing okay. Alright. Run the 1000-watt scale. Oh, so we're going to be putting about 50 or 60 RMS into it. Oh, then right there about 100 peak or so. Oh, a little bit over 100 peak. Okay. The driver's on 14.5. Alright. Now I'm not going to leave this on too long when I got the fan off, okay? Because none of that's voltage protected. When I turn this on, I'm going to hit it and turn it right back off. I don't want to cause any damage to the, blow any resistors on the LEDs. Alright. Right there about 720, 750 or so RMS. Alright. Now I am going to have to put in a bigger slug so we can see what it's doing on the peak end of things. Where is it at? There it is. 2500 watt slug. Alright, and I am AB biased right now. I got it on AB. Alright, so here's your peak, 2500 watt slug. We'll be reading the top scale. Where the 10 is, that's 1000. Alright, turning it on now. Ooh. So right there about, what is that? 1350 or so. 1350-ish. Okay. Alright. So yeah, it isn't doing as much output as the last 1600. It just is what it is. That's just what the output is doing. Everything's good to go. I mean, there's no input reflect. The output looks great. So that's just what it's doing, my friend. Alright, so like I said, this thing's got a Class C option. And by the way, the voltage drop on that, let me see real quick. It's 15 volts even. Okay, it's 15 volts even. And we're only driving 100 watts into it PEP. Alright, give me 1 second. We'll hook up the old 2-pill. And when I do that, I'm going to take the 2500 back out and put the 1000 back in. And basically do the same thing we just did. And still, I'm just letting you know, if this was my amp, if this was my amplifier, I would just hit it with the 1 pill and let it be. Okay? I would just hit it with the 1 pill and let it be, if this was my amplifier. But to each his own. I'm just going to drive this in the Class C, because Class C does allow you to drive a little bit more power to an amplifier. But still, this is not designed to be a big mall box. And as we already talked about with the power wire upgrade, don't get me wrong, I could do a power wire upgrade to this box, but it will require a good bit more of labor to even get to the, well, I'm talking about a full power wire upgrade to the back of the transformers and everything. To me, it just doesn't do a lot to change all the power wire but still have a tiny choke right here. You know, that's like taking a water hose and hooking up a water hose to it that's 10 times bigger in diameter, but still hooking up that same small water hose to that. I mean, it doesn't do much for you. It might make it, I guess, spurt a little harder, but you want it to be just about the same, you know, a lot bigger, so the flow can flow through there a lot better without being held back at all. And like I say, these two right here, no problem. I can get to these, no problem. If you look at this, you've got all these wires to get my iron back in there to solder to the back of that transformer. I mean, come on. To this one, it'd be a little easier. I could probably come in up under there. But this one right here, you see where the choke is down there. I could get a wire down here and all, but I'd have to stick my iron in between here. The best thing would do is unsolder all these wires. And then on the back here, you're pretty much subjected just to these 4 holes, which, you know, is fine. That's no problem at all. But you have 4 boards that you need to get some wire to. So like I said, I could do it. And if you still would like me to do it, I can still do it. I got to add a little bit more time to it. But it is what it is, my man. Alright, we got 2 minutes left. So let me go ahead and press pause and get this 2-pill hooked up. I'll be right back. Alrighty, we got the 2-pill 1446 box. 2 1446s. Okay, that's going to be putting about 100 watts RMS into the box. Class C. And this yields us 1000 watt slug. Go. Right there, about 800 to 850 bird. While my one of my thing is coming unfocused. All right, putting in 2500 watt slug. See what the peak is, just for the fun of it. I'm an RMS man. For all you peak lovers, let's see what she's doing peak now. Alrighty, reading the top scale. Go. It's 14.8 volts too. I just looked over there. All right, I think that was 1850. I think. Let's see, 1500. 1700 watts. 1750 watts, I believe. Alrighty, that's 14.8 volts. Alright, bud. Real quick, I'm going to press pause and hook up the radio, show you the input reflect. I can't show the input reflect on the hot radio. I know y'all been seeing this same old cheap, cheesy setup here on all these benches here for a year, 2, 3 years now. One step at a time. I'm going to be getting into an actual shop. It's in the making. It's a very slow process, and I'll have me a good bench set up with everything looking pretty, but pretty don't always pay. Like my buddy Stickman used to say, show, don't go. But there ain't nothing wrong with making something look pretty, but as long as it works good at the same time. Because if it just looks pretty and don't work good, what good is it? What good is it, right? Alright, be right back. Alrighty, got the fan on since I'm on unregulated supply. And I will be honest with y'all, I don't quite know yet what this switch is for. I need to look at the schematics, because look, it just turns the amp off. I don't quite know what that switch is for. I'll have to look at that. Maybe that's a function that's maybe the 1600V or something. I don't know. I'll have to look at that. I mean, it's just power going into it, going over here to the fan, it appears. But it cuts off all the voltage to the switches and everything. So I don't quite know what that's for. Huh. But anyway, alright, I just want to show the input reflect. And check this out. Like I said, this relay right here only actuates when you're on Class C. The input tuning capacitor, the load, is 120 picofarad capacitor. It's right here going to ground. This is the main splitter that splits off the RF that direction, this direction. This direction feeds these 2 pills. This direction. So these 2 pills aren't actually together. It's done in this way. These 2 pills, the two pill sections, these 2 pill sections. If you just looked at it, you would think, you know, because you're used to it being like that, you know, these 2 together. But that ain't the way it ain't the way Texas Star done this on this one. The way it is these 2 pills. This 4 pill section right here combines this 4 pill, and then this right here combines both 4 pill sections. See what I'm saying? That's the way it's done, and this is the splitter for both 4 pill sections. So anyway, once you go to Class C, this engages and adds a 68 picofarad capacitor to the 120, and you can see there's a difference in the input tune on each. All right, we're in AB mode, right? Look at the input tune. 10 watt slug. or the input reflect. Oh, oh! All right, now watch me go to Class C. Oh, oh! It's a little bit less reflect. The only thing I notice there's a little jump on Class C. If you go to AB, it's a little quicker jump and it goes back. So that's that relay engagement is what you're seeing. So that's the first time I'd ever seen that in an amplifier before. I've thought about it just, you know, in theory. Us amp builders and repairmen and all that, we're always sitting there thinking of a theory of how to do something different, or just, I wish I had the time just to play. God, I wish I had the time just to play. I have all kinds of cool ideas I'd like to try out. But y'all, we can't reinvent the wheel. We're just trying to make that wheel look neater and trying to make that wheel spin faster. But we can't actually reinvent the wheel itself. Old Gatekeeper out here around the northeast end of Georgia. 73s. Kevin, thank you for hanging in there with me, my friend. I know you about gave up on me, and I don't blame you. It sucks waiting on stuff, man. Waiting sucks. Waiting really sucks. But hopefully I can get some help up in here, man. Gatekeeper is looking for an apprentice. I'm going to go ahead and put the word out there now. I am looking for an apprentice. I am looking for someone that was in my same footsteps about 6 years ago or so. I would have killed to have been able to sit up under someone that was doing this to learn. I would have worked for free from 6 o'clock to dang 12 o'clock in the morning. I would have worked for free, not even wanted $1. Which, of course, I won't do that. But I'm just saying, that's the kind of attitude I had. I wanted to learn this so bad I could taste it. That's the same way I feel right now of wanting to learn tube type equipment. Oh, hell yeah, man. I know it's dangerous and all that, but I want to learn it. I want to learn old school tube type equipment. I want to learn how to build, of course, steel tube amplifiers, of course, the big mules. You know, I know a little bit here and there, just enough to get myself in trouble probably, but I want to learn. I want to learn anything I don't know. And there's always more to learn just in this, in solid state RF amplifiers. If you want to see how deep it really can go take a look at some ham amplifiers. Go take a look at a Meritron 600 that a Meritron makes. 42879, 10 through 160 meter, full output filtering. Go take a look at that amplifier if you want to see how deep this stuff really can get. Old Gatekeeper just wants to go as deep as the rabbit hole will allow me to go without my big butt getting squeezed in the hole, you know, and stuck. I just try to keep everything true, keep everything honest. If you ain't honest and you stretch the truth or something, it's just the way the circle of karma works. It always will revolve around in a negative way to you. As most of you probably already know, Old Gatekeeper's a believer in the big man upstairs that sits on the circle of the universe. Yes, I am. I would be dead without him. I don't care what anybody says about that. I would never deny the big man. Of course, he ain't a man, but you know what I'm saying. And it's just the way the circle goes, man. Any way you want to look at it. So I just try my best. If I ever make a mistake or something in the past, it ain't because I made the mistake because I knew better and I just done it on purpose, trying to do somebody wrong or something. It's just because I didn't know any better. Like, for example, I shouldn't be getting into all this on this video, but it's just struck up in my conversation. Back when I started biasing, I was taught how to bias the wrong way. I'm not going to say who shared that information with me way back then, but I was taught how to bias the incorrect way by actually grounding the input transformer. So a couple of boxes that I biased that I was calling AB bias boxes were actually Class C, but I didn't know it. Because when I was sitting there looking at it, not keyed up, with no RF on it, checking out, I'm sitting there looking at 0.68 volts on the base. So, I thought it was biased. Hell, old gatekeeper even ran a 4-pill amplifier, the very first amplifier I biased using this circuit that was shared with me, which I don't think he knew better either. I think he truly thought it was a biased circuit as well. Real funny, all you had to do is take the choke off the input transformer and it's biased. But I ran a 4 transistor amp for probably 2 or 3 years on sideband, thinking it was biased, and really had never had anybody tell me, you sound distorted or da-da-da. Never even had that happen. Maybe one time, I think. But but as I got into this and learned more and more and more, I learned it all by myself that wasn't biased. Palomar 600s are done the same way. I'm sure a lot of y'all know that. But once I learned, I try to contact a few guys that I built them amplifiers like that and apologize to them, and basically let them know, hey, you just take the choke off the input transformer, just unsolder it, or just unsolder it from the ground, and you'll have a bias voltage at that point. So, but I think I'm gonna be making another video about that soon, because there is a picture on my Facebook that somebody's posted. I hadn't removed it, but somebody's posted it showing a picture of a 5 transistor amp that I did like a AB/C switchable deal. But the crazy thing about it, when you switch to AB, it still goes Class C. But I just didn't know any better. I think that was like 4 years ago or so, something like that. But anyway, I'm trying to get better in that department too, and get into some fully regulated with tracking for the sideband lovers, for the bias lovers. But at the same time, building these big malls. Hey, I like both sides of the spectrum. Linearity and pure nasty distorted mall dropping killers. Alright, let me get on out of here. 73's y'all, old gatekeeper right here around northeast in Georgia. I'll go ahead and get this top back on here for you. By the way, so nobody else makes the same mistake I did with a buddy of mine, he knows who he is. When I first tried to take a top off one of these, I tried to take the top off of it with these out like this, and all these just fell off. And I think it actually broke something. Whenever you try to remove a top of these amps, always push these buttons all the way in. And when you unscrew, begin to move the top back a little so these clear this hole right here. Then take the top off, and it comes off just like this right here, as you see. So nobody else makes the same mistake I did the very first time I tried to take the top off. I was sitting there taking it off in my driveway to look in it, because he brought it over, and I'm like, man, why ain't the top coming off, man? This is weird. Then all of a sudden, these right here just fell off onto the ground, Oh, okay. What the heck, man? Why did that happen? Oh, I see why. All right, y'all. God bless. 73. Gatekeepers gone. Bye, bye, bye.